Greetings, one and all. Beautiful day for a webinar. Thanks everyone for dialing in so far. I'll give people an opportunity to come through the virtual turnstiles and greetings to everyone who's putting in that hello and hey and how's it going? I'd also like to pay my respects to the traditional owners of the land in which I'm presenting from today, the Turrbal people. And I acknowledge them as the traditional owners, and I pay my respects to their emerging leaders and leaders past, present. And certainly where I'm calling from is a very different location to what it was like 200 plus years ago, and it's certainly changing dramatically. There is a lot of development pressure. Where I'm calling from in southeast Queensland. Just a recent report was talking about how by 2046 there's going to be another 900,000 homes. So another 2.2 million people coming to southeast Queensland. Hence, there's a lot of pressure on development assessment staff in council when it comes to reviewing the stormwater management plans, the music models, etc. And hence, why we're doing this webinar today, give a bit of a little bit of insight from my perspective, and I'm just one person in relation to maybe some little things to keep an eye out for when you're reviewing development assessments, if you're in a council capacity, but also if you're looking at reviewing reports or designs or models if you're a designer or a consultant. We originally thought this webinar was going to be focused on council staff, but we've had over 685 registrations already, and there's obviously a lot of council staff. I think by memory that I saw about 50 from Brisbane City Council alone, which is fantastic. Shout out for Bo Reichart for promoting that. And also, while I'm thinking of it, a big shout out to Peter Kuras from Brisbane City Council. Peter Kuras gave me essentially the original idea for these fundamental series. We were originally going to do one webinar, and it was about this topic, development assessment. Also, but obviously, it's blossomed since then. We've done this is I think the 10th. I think done this year. Thanks to Peter Kuras from Brisbane City Council for giving the idea of doing this fundamental series in the first place. And again, thank you so much for everyone who gives up their time. Whilst I give people the opportunity to come through the virtual turnstiles, because I see them coming through. And but look, very quickly, just a shameless plug on a few Ocean Protect related news. You might have seen we've recently released our Stormwater NP technology. In summary, it's just like our Stormwater P-Sorb, and prior to that, Stormwater ZPG. So same Stormwater technology, just with a different media. To date, we've put in 38,000 Stormwater technologies around Australia, stopping a hell of a lot of pollution. And we've just done we and others have done some performance testing of the device, got it squid up verified, and long story short, it's available, released to market. It's basically just like the P-Sorb technology, except different media mix, and it can operate at a higher flow rate. If you're keen to know some more info about that, just reach out or jump on that website link there. The other thing worth mentioning is obviously this is number 10 of the Stormwater Fundamental series. We've got two more after today. We've done 9 already this year. If you've missed out any, you can just watch them via the link, the webinars link there. So each of our webinars, we provide the recording and the slides. And a lot of people watch them later, which is great. But also, I'm actually pretty excited to announce today, this is hot off the press, that we're actually got details of the first up, I actually jumped ahead of myself. The Tasmanian Stormwater Symposium is happening in November. So if you're a local in Tassie, feel free to get along to that. That'll be, if you want to check out the oceanprotect.com.au news webpage, that'll have a link to the registration, or you can just Google Tasmania Stormwater Symposium. It'll come up. I know we're offering early bird tickets, which I think are almost all gone. So if you're keen for an early bird ticket, that's limited to 25. Jump on to that fairly soon. But what I was really going to announce actually was the fact that we've actually, due to the popularity and the feedback from the first year of the Stormwater Fundamental series, we're gonna do it again. So 12 more. Basically, I guess, similar format structure to this year's. So, and we've announced confirmed the dates and the presenters. So it's on. You can see the topics there. We've got E-Water presenting on the first one. We've got Sean Quilty presenting the next three. I think we've got Murray Powell presenting a couple. Daniel Rhodes from Optimal Stormwater presenting one. Ian Adams from Organica Engineering is presenting on number 8. Yeah, so a lot of cool stuff to learn, all free, all on a Wednesday lunchtime throughout 2025. If you're keen to register or find out more when they come out, just jump on those links you can see at the bottom of the page. So that's pretty cool. Um, and look, before I dive into the main presentation, just a conflict of interest declaration. So yeah, obviously I work for Ocean Protect. I'm their principal environmental engineer. Ocean Protect do make money from selling stormwater treatment assets. So we make money out of installing them and maintaining them. So just keep in mind that I do have a conflict of interest in this space. But I've tried to be, throughout the presentation, I've tried to be as transparent as I possibly can. But yeah, it's just worth noting that, obviously. And just a reminder, folks, if you do have any questions you'd like to ask me today, please put them in the Q&A panel. Actually, I should point out, it was supposed to be myself and Harut from Ocean Protect coming along today, but Harut can't make it, so you're stuck with me. And as I mentioned before, the slides and recording will be made available at that web page there. And if you do have any CPD form requests, please email them email any requests to that email address you can see there. And I know that a lot of people have been waiting for CPD forms. I promise next year it'll be a lot more efficient, so a lot less emailing back and forth. Just as part of your registration process, you'll basically just nominate whether you want a CPD form, and one will be automatically sent to you after your attendance of the webinars next year. So trying to make things easier for you guys to rack up your CPD points, etc. Cool. Let's just dive into it. So first thing I want to talk about is just targets. So when it comes to stormwater management plans or music models, we generally have targets that we are required to achieve. They're generally something like the classic 80, 60, 45, 90 targets. So something like an 80% removal of total suspended solids, 60% removal, or something like 45% for phosphorus, something like 45% removal for nitrogen, and 90% removal for gross pollutants, or thereabouts. I know it changes from location to location, but it's worthwhile noting, and I talked about this in the last water sensitive urban design webinar, they really are really just bare minimum targets. So they are, and they don't necessarily guarantee the appropriate protection of downstream waterways. It's really just what is considered practical if we used bioretention systems. So it takes nothing into consideration in relation to the values of the waterways, but generally, even with compliance with these targets, we still see a residual impact, a negative impact to downstream waterways. But again, my point is they should be the bare minimum as to what we're trying to achieve. And obviously that's just water quality. As part of stormwater management planning and water sensitive urban design, there are obviously targets that we're trying to achieve. Often flow reduction, mimicked catchment hydrology, sometimes urban cooling, make the site look good, reduce potable water demands, etc. But getting back to the nutrient and solids and gross pollutant targets, it's worthwhile noting that they are critically important. And just as a trigger warning, on the bottom left-hand screen, I'm going to show a picture of a dead turtle. So if you're squeamish or don't like seeing pictures of dead turtles, please look away now. But it's worthwhile noting that um, the targets that we're designing our devices or strategies to achieve are important. It's not just an academic exercise, it is an important thing. And non-compliance with those targets only worsen the impacts on our downstream waterway ecology and ultimately the values, which might be amenity, social, cultural, and human health related as well. So obviously dugongs are a big issue in Moreton Bay. If we smother their seagrass meadows with sediment, that obviously impacts them. Obviously, if we have excessive amounts of nutrients in our waterways, that can cause algal growth and eutrophication, which causes obviously ecological impact and often human health impacts. And obviously gross pollutants, the litter plastics, obviously can have a significant impact on the health of our waterway ecology. And those impacts are pretty well established. When it comes to, I guess, development assessment, I often ask this question of councils and engineers. Ultimately, who is responsible for making sure that the strategy is appropriate or functional and is actually achieving what it's supposed to? It's interesting. I get the feedback from engineers or consultants saying, if council approve it, it's on the onus is on council to make sure it's hunky dory. Council will say, no, no, the designers are responsible. They designed it. We can't, obviously review every a minute detail of their design. So engineers are responsible, which often means no one's often responsible, which obviously is no good for anyone. But fundamentally, what we're trying to achieve with, I guess, appropriate storm management planning and water sensitive urban design is good outcomes. And I think we all need to take some level of responsibility. So I'd suggest certainly, as a former consultant, I'd say the significant onus should be on the engineer or designer or the consultant to get the storm management strategy correct. And councils should not be held responsible for making sure that that design has been done properly. They do the best they can with the limited resources they have available. Often there's a 20-day time turnaround for development assessment, which is not long at all when you consider all the work involved in terms of review. But look, that's just my perspective. But what I'm hoping to show today is that there's a few things that often do. There's a few things that it's worthwhile keeping in mind, in particular, to I guess try to achieve a more water sensitive or better outcome for our environment and ultimately everyone. So in terms of development assessment, when it comes to stormwater quality management, for me, these are the key considerations that really stand out just from my perspective. And I have been doing this a while, like 20 years of doing stormwater quality management, water sensitive urban design stuff. For me, these are probably the doozies that stand out in terms of the things that often are done incorrectly and can lead to particularly bad outcomes. So integration, water quality, and hydraulics and mass load, and I'll talk about those now. So first up, integration. The key for me, the key considerations about when it comes to getting integration of assets, so bioretention, wetland swales, GPT, squids, right? These are it. So maintenance, access, safety, area usage, and amenity. So if I show you some examples, so these are good examples of good outcomes. Really good amenity, really good sauna treatment function, maintenance, access, etc. Ticks all the boxes, and there's obviously a lot of examples like this across Australia, which is great, obviously. So these are bioretention systems, for example. This is a Filterra bioretention system. It was a very constrained site, but we managed to integrate it appropriately. For me, I love showing this photo. This is an example of a Filterra bio retention from the States. It's a leaf-shaped Filterra system, and uh, bizarrely, we're actually looking to do a very similar design as we speak for council in Victoria. But yeah, I think for me, this highlights the fact that we can really achieve really good integration outcomes. But obviously, there's examples where that hasn't been achieved. So whether it's a GPT like this on the Gold Coast, which you physically have a lot of difficulty accessing to clean out, so it's under a tree, and the vacuum truck has to park on the footpath, which probably cracks the footpath every so often, and probably increase the trip hazard risk of that footpath. And then you've got devices like this that physically can't be accessed at all. This is a sedimentation basin. Previously, it was like 2 meter deep of water, and it just filled up with sediment because it physically couldn't get accessed. And then you got obviously examples of various, particularly bioretention systems that just have are fairly poorly integrated. And I'm sure everyone's seen examples of these where basically someone's dug a hole, filled it with filter media and some plants, and put a dirty great big fence around it. And I think everyone on this webinar would agree that this isn't water sensitive urban design, but unfortunately we often see this. So again, one thing to keep in mind when it comes to your development assessment or development review would be just trying to make sure, to the best of your ability, making sure that the integration is done properly. And this is a classic example. This is the one in Brisbane, in Brighton. Retaining walls on all sides of the bioretention. This is the bioretention system, by the way. Retaining walls around all sides of the bioretention system. There's like a 1.5 meter or 2 meter drop on the downstream side, and obviously high retaining walls around the whole thing. And to get into the system, you have to climb via a ladder into the bioretention system. So very, very difficult to access, maintain, etc. And obviously, this is just a bad outcome. And obviously, there's lots of examples like this. Not shaming McDonald's in any way, but this is obviously a pretty average bioretention system, but they're not alone. And then it's not just a water quality function, often it can become a public safety hazard. And I've shown this example before where, just don't just fall into the bioretention system, you probably trip, and by the time your head reaches terminal velocity, it's probably coming into contact with a concrete edge on the other side of the system. So we laugh about it, but it's obviously it does happen, and it's certainly through appropriate design review, and maybe development design assessment. In council's perspective, we could have avoided something like this happening. Sometimes the easiest option in terms of achieving good integration is just putting it below ground. Now, again, conflict of interest, ocean protect cell devices that can be integrated underground. But from my perspective, it's often the best solution particularly for a constrained site. And a lot of sites are highly constrained, even with the best planning, conceptual design in the world. So in this case, for example, we can put in a detention tank or a chamber as part of the civil construction, and then just cover it over with, in this case, asphalt, but it could equally be landscaping, grass, etc. And then obviously you can easily access these to maintain via a sucker truck or whatever. The pollution is away from the public, so there's no risk of that contact. And it's basically easy to maintain. So that's some sort of, I guess, some key, a quick overview of some key considerations when it comes to integration. Let's talk about water quality now. And it's worthwhile noting that water quality and hydraulics they basically go together hand in hand. And I'll explain that in a sec. So a key assumption when it comes to stormwater treatment assets is that they will function as intended. So when you're setting up your music or whatever model you use, there's a key underlying assumption that the system, whether bioretention or wetland or GPT or whatever, will function as intended. And there's a whole bunch of assumptions that go into that. So first up is the fact that you're assuming that the asset's going to be in good condition, number one. Number two, you're assuming that the treatment system is fully utilized. And also, particularly when it comes to sort of, I guess, proprietary devices, and again, full disclosure, we make proprietary devices. There's an assumption that everyone can be trusted when it comes to their performance claims. But unfortunately, time and time again, that's shown not to be often accurate. And I'll show some examples in a sec. So in terms of that assumption being wrong, these are some common problems that I see. Sediment and lead over accumulation, number one. Sometimes the treatment device just isn't fully utilized to its full extent. I'll show some examples in a sec. Optimistic performance claims I touched on, and just poor maintenance. So show you some examples. This is, for me, is a classic, and I still see this time and time again, even with all the fancy guidelines around proper construction establishment. I often see bioretention systems in particular smothered in sediment from upstream catchments, often from if they're constructed too early, as in the construction phase works are still happening upstream, they'll often get smothered in sediment. And I was just looking at a project just a couple of days ago around this. Won't mention where, just because I think they're actually tuning into the webinar today. But this is a common scenario, unfortunately. But even construction phase sediment loads aside, and we know that they're higher than the operational phase or the fully developed phase, we still see a lot of pollution coming from fully established urban catchments. And I've shown this example before. This is what we pulled out of. We had 8 gully pit baskets, 8 ocean guards in a pretty stock standard street in Western Sydney, and they were in the ground for 5 months. So just 8 ocean guard gully pit inserts in the ground for 5 months, treating a reasonably small catchment, and you can see what we pull out. So, and this is again fully established catchment. So a bunch of plastic, bunch of everything, typically single-use plastics, obviously a whole bunch of sediment, and that stuff isn't just going to magically disappear. That's going to have to be manually removed from, in this case, the devices. But also, if the devices weren't there, that'd just go straight into a downstream waterway or other, secondary treatment device. And I showed an example of a bioretention system full of litter the other day on LinkedIn. If you've seen that, and obviously we've got a whole bunch of photos of end of line GPTs full of sediment, full of litter, etc. And and these are some photos courtesy of Dan Rhodes, I think, is on the call today. Yeah, this pollution just doesn't magically disappear. It needs to be appropriately maintained, and obviously, if the GPT is completely full, it just won't work. Okay, so the assumption that it's working is often not accurate at all. And another example of this is from Ralph Leiter from Wave Consulting in Victoria. This is a little some bioretention systems in Little Collins Street, um, just full of sediment. So Little Collins Street, fully urbanized, nothing but shops and roads and all that sort of stuff, just full of sediment. So I think a lot of stormwater professionals forget that you can still get a lot of gunk, even sediment, from completely urbanized environments with no exposed soil. I remember Ralph's talking about how there's a lot of hair in these bioretention systems. So yeah, a whole bunch of gunk comes from our urban environments, unfortunately. And bioretention systems are a physical filter. They obviously have biological processes happening, but that sediment, that litter, is it will accumulate, and it obviously needs to be removed. And if it doesn't, the system probably will have an impaired function. Another example, this is new jellyfish tentacles going underground, and that's what they were like, or what they can be like after they've been in the ground for a while. So again, new jellyfish tentacles, membrane filtration. For me, it just shows you what is in stormwater. This pollution, the hydrocarbons, the dirt, the microplastics don't just magically disappear. They need to be appropriately maintained. And if we just leave these assets in, or if they're undersized, etc., they will not function as intended. Also, a common thing I keep seeing with bioretention systems, and particularly bigger bioretention systems, is there's an assumption that the water just magically spreads over the entire system, because that's what music assumes. Music assumes that water comes in ponds and then drains down equally across the entire filter media surface. The reality is that just doesn't happen for these bigger systems. So this is I think a one in, I think, Ipswich by memory. Can't remember. I took the photo now. Inlet coming in, and you've got the outlet pit immediately adjacent to the inlet, and obviously you've got areas that are still within the bioretention system that will probably struggle to get much water at all. Obviously, if you get a whole bunch of water coming through, the whole system will pond, etc. But yeah, in the majority of events, the small frequent events, the water will basically dissipate around the inlet, and we see that time and time again. So just again, the model not matching the reality, unless it's appropriately designed with good flow distribution. This is another big system out at Mackay, a very long system that, again, just probably another example of poor flow distribution. There's an assumption that the entire system will be engaged in treating water, but it just won't happen. Often the plants will die a very slow and painful death. And this is another classic example. This is out at Fitzgibbon Chase in Brisbane. There's quite a few of them like this, or at least last time I looked. The water will come along obviously via the curb, and the water go into this is supposed to be a bioretention system, a curb cutout, and the water comes in via this curb cutout, the inlet, but the outlet pit is immediately adjacent to the inlet. Obviously, there's no plants, but this will obviously not function anything like what is modeled in music. So again, just poor design means, and poor implementation means, the system will not function as intended. And like I said, there's a few of these already around Fitzgibbon Chase, or at least there was. I'm hoping council might have fixed them up by now. So key recommendations in terms of this, I guess, water quality and hydraulics, integration pieces. And I guess this is like a bit of an overarching statement, but there's a real need to make sure through your design review, design, et cetera, that the assets or assets will function or likely function as intended. A key thing I keep seeing is that maintenance access, appropriate maintenance access, isn't provided. This is essential. So again, as part of your design review or construction establishment review or handover, making sure that at the very least, the assets are appropriately accessible for maintenance is absolutely essential. Obviously, during the construction establishment, there should be some sort of review and inspection. Obviously, Water by Design and others have a whole bunch of checklists that you can do or complete to help achieve that. And if for privately owned systems, and I'll touch on this later, it's for me, it's essential that prior to any development approval, there's some requirement for ongoing condition assessments and maintenance of any assets that are put in the ground. And again, obviously, when it comes to operation, there's a requirement to do checks to make sure the assets are appropriately functioning as intended. And if you're in council or a regulatory authority, ideally you review and enforce the condition assessment and maintenance requirements that are ideally agreed prior to development approval. I'm going to touch on proprietary squids quickly. I guess the key thing from my perspective is the exaggerated claims around performance. So whether that be water quality or hydraulics or maintenance. And this is probably an example of a device that I would perceive as making an exaggerated claim. So this is straight from their, I won't mention the device's name, but this is from their website, at least historically. This device claimed extremely high rates of pollution removal, so 100% removal of litter, 99.95% of oil water removal, 97% removal for phosphorus, and 95% removal for solids, and 85% removal for nitrogen. So no fancy absorption or biological treatment processes going on. It's basically relying on physical processes. And I'd suggest that those claims are extremely high. But if you look at the data that the claims are based on, I don't think it's appropriate I don't think the data that's available, or at least the data that I've seen, would be enough to appropriately substantiate those claims in the real world. And I've taken this is again from the same company's website. This is the information around their performance claims, and for me there's a few question marks on the methodology used to substantiate those claims. So for number one, there's no real world testing for this device, or at least cited, and it's purely based on a lab scale assessment, and it was based on one test. And they took samples, I think 2 samples on the inlet, 2 samples on the outlet, and they even acknowledged that all the nutrients were dominated by particulate forms. And we know that dissolved nutrients are certainly present in the real world, but they did a mix of their own pollution, I guess, and dosed that and took samples in the inlet and outlet, and that's what they based their claim on. They did the testing themselves, which again, I'd question the independence of that. And again, it's not, that is a lab scale test, which invariably isn't accurate to reflect real world performance. So again, I'd question the claims, and I'd suggest that they're probably optimistic. To give you an example of this in the real world, and another device. This is a gross pollutant trap. This is a project that I've just come across my desk just recently. This is a project in Brisbane. So just a development, and the development is proposed to drain to a gross pollutant trap, and this gross pollutant trap will achieve, according to music, extremely high rates of pollution removal. So 82%, 80%, 50%, etc. And that's extremely impressive for a gross pollutant trap. If I was in council's position, or if I was reviewing that, there's a couple of things I would check as an example. And this is something I'd probably suggest I'd be doing if I was in council. So first thing I'd look to check would be the high flow bypass. So again, this is when I talk about hydraulics and water quality go hand in hand. So to do that, you double click on the treatment node, the GPT, and you'd probably check the high flow bypass rate. So just make sure that the high flow bypass is actually relevant to the GPT specified. Now, this is something I see time and time again. A small GPT will actually be proposed, and obviously have a certain cost, but they've actually modeled a much larger, more expensive gross pollutant trap. Or something, or a device with just a really high treatment flow rate. So how GPT and any generic treatment node will function will remove pollution up to a certain treatment flow rate, a high flow bypass. Anything above that is bypassed. So any GPT or other device, or like a proprietary cartridge, for example, will have a ability to remove pollution up to a certain treatment flow rate. Anything below that flow rate, it's treated to that standard. Anything above that flow rate, that high flow bypass, is bypassed. So this for me is a key thing to make sure that you're checking in terms of the music model. So making sure that's okay. But the key reason why this in this scenario that the performance claims are very high was, and again I blacked out certain things just to protect the I guess the anonymity of the yeah, you know what I mean. How do you say anonymity? Anonymity of the people involved is their generic, sorry, their GPT transfer functions or their pollution removal rates, which they've plugged into their GPT node, are just higher than what's actually approved by, in this case, Brisbane City Council. So Brisbane City Council have nominated a certain amount of pollution removal that is acceptable according to their processes. And that's a debate as to whether that's appropriate or not. But that aside, council have their own approved performances, but the model itself has actually applied far higher pollution removal rates than what's actually approved by council. So again, this is just something that if I was in council's position to check development assessments, number one, I'd be asking for the music model. Obviously, you need a license in music to open a model. These, for me, are the key things I check: the high flow bypass rates and the transfer functions within the GPT and all generic treatment nodes. Another example is of just sort of, I guess, optimistic modeling is just stuff that just can't be done. So in this case, from a review of the design drawings, it's just physically impossible for these catchments to drain to, in this case, it was some sort of GPT. So fundamentally, hydraulically impossible. And again, it's just something that we do see, unfortunately, in some situations. Again, this is another example. I probably maybe accidentally made a mistake using the same land use for different parts of the catchment, but using different pollutant export characteristics, which by memory gave them a favourable result. So yeah, again, unfortunately, when it comes to review, it's a good idea to check the music models, and in this case, make sure that reality is going to be appropriately represented in the music model. And then you've obviously got the claim. So I mentioned that claim before about that one device, claiming, I don't know, 97% removal for phosphorus. And there's a tendency of just wanting to believe these values, or you believe just what council will accept. So a lot of people say, oh yeah, I don't believe this device actually works this way. But council say it's okay, so it must be okay. I just don't buy that at all. So while some people want to believe, my advice is trust no one. And full disclosure, former X-Files fan, hence the references. But yeah, look, if I was to provide any advice in relation to reviewing performance claims, I'd actually just ask for the proof. So if someone wants to make a claim about their individual device's performance, I ask for what the proof that has gone into substantiating that performance claim. Now, I can provide some advice around what you should ask for, but they should just provide that, and it should be provided without any distribution restrictions. So you could take that proof, for example, and give it to someone else like me or whoever to do a third-party review. And you're never going to get a better reviewer of a performance claim than probably their competitors as well in this space. So yeah, I'd certainly ask for proof. There are protocols available though, so I think most people on this call would be familiar with Stormwater Australia's SQUIDEP, which is the Stormwater Quality Improvement Device Evaluation Protocol. That does provide a procedure and a process to verify and determine verification for the performance claims for proprietary devices. To the best of my knowledge, and I might be wrong, this is only currently applied in some parts of southeast Queensland and the Aerotropolis in Western Sydney. So it hasn't really got wide distribution for a bunch of reasons, and fundamentally, it's not currently endorsed by Stormwater Victoria and Stormwater New South Wales or Stormwater Queensland, probably because there are some known deficiencies in the process. But fundamentally, 10 devices so far have been verified via this SQUIDEP process. So that means Stormwater Australia have given us verification certificate for 10 devices, saying those devices comply with the SQUIDEP requirements. And those 10 include 4 from Ocean Protect as well. So is it perfect? No. Is it widely applied? Not really, at least external to Southeast Queensland, but it's at least something. Certainly I would suggest that the device I showed before, in terms of its 97% total phosphorus removal, probably wouldn't get that sort of performance verified via anything like the SCWDEP process. The other alternative is to look at what other councils have done, and probably the leader in water sensitive urban design in Australia is Blacktown City Council, and they have gone through the trouble of reviewing a bunch of proprietary devices and determining their council approved performances, and they actually provide these nodes as part of your music license as well. So for me, this is actually a pretty robust and suitably sort of, I guess, independent, verified process. And a bunch of assets have already gone through that process. Again, is it perfect? Probably not. I'm sure it's a lot of work for council, but at least it's at least something to sort of look to consider when you're reviewing the performance claim. But fundamentally, I just wouldn't buy into the process of just accepting the claims and saying, oh, as long as council accept it, or as long as the manufacturer has provided some sort of verification, that's all hunky-dory by my mind. No, that's something I definitely would not recommend. What I would recommend is, again, asking for the proof with no distribution restrictions. Consider providing that proof to others for independent review if you haven't got the expertise or the capacity in the space to review it. Or review and consider the SCWDEP and/or Blacktown City Council approved values for those proprietary devices. Yeah. Hopefully that'll, if I'm honest, I'm hoping in the years to come, this will improve because it's a little bit of it's confusion. I know it's a lot of work for individual councils if they want to try and develop their own process and apply it. Hence why some councils, at least in Southeast Queensland, have applied SCWDEP. So I don't belittle the fact that there's a lot of work involved in doing this. But my recommendation remains is to not just blindly accepting whatever the manufacturer accepts, or even what council would accept, because often councils don't have the resources to appropriately check the performance claims of every device on the market. Then it comes to maintenance. So the key thing from my perspective is all assets need maintenance. So whether it's a GPT, bioretention system, wetland, whatever, they need maintenance. Okay. A recent condition assessment of a bunch of bioretention systems in Moreton Bay on the left-hand side showed that, about half were in good condition, half not so good. And about 17% needed some significant rectification works. Similar, a decent-sized council in Queensland, or Southeast Queensland, found about 22% of their bioretention system had need major rectification works. And again, this is, I recognise I'm quoting myself here with all the ego in the world, but a lack of maintenance activities is predicted to be the key reason for these poor ratings. It's not just me that has said this previously. Andrew Thomas, President of Stormwater New South Wales, and others did a review of a bunch of assets a few years ago, and basically, again, same finding. The maintenance or lack thereof is the leading cause of high proportion of assets being in poor condition. So all assets need maintenance. Okay, so there's a bunch of must-haves. You need to regularly remove the pollution. To do that, you need to know where the assets are. You need to know what they are, and you need to have the resources, obviously, appropriately maintain them. And that's applicable for both publicly and privately owned assets. So recommendations in this space. Obviously, no-brainer, ensure assets can be safely, easily, and appropriately managed. Obviously, that management needs to be done by suitably qualified personnel, and maybe they might want to consider doing the Stormwater New South Wales maintenance training, and the guidebook is there on the bottom right screen. For private sites, again, consistent with my advice before, is prior to development approval, require a long-term maintenance agreement, and that agreement should be reviewed and enforced. Now, I used to actually, when I've given a similar sort of training before on this topic, I used to say just use what Blacktown City Council, their development assessment conditions. But more recently, you would have seen Ocean Protect and Daniel Ryder in particular helping develop a WUSID maintenance compliance framework. And that's had a whole bunch of involvement from a whole bunch of stakeholders. It's endorsed by the likes of Stormwater Queensland, Stormwater New South Wales, Optimal Stormwater, all the cool cats. And this actually, I know it's a big document. There's a lot of information, a lot of work's gone into it. But if you take nothing away from this webinar, what I would suggest if I was in council, I'd actually just go straight to Appendix A of the Woodford Maintenance Compliance Program, and have a good look at the conditions. Sorry, the development approval conditions, and it's all about just making sure that assets are appropriately maintained. So you can literally copy and paste the words just straight out of here and use it in your own development approval conditions if you're in individual councils. And they're based historically on a little bit of Blacktown City Council and probably others, but you can literally just take these verbatim. Obviously, you can review them and apply them to make them relevant to your sort of LGA. But for me, the hard work's been done, at least in terms of developing appropriate wordings for development approval conditions to help um, uh, ensure the appropriate maintenance of assets on privately owned sites. So if you're keen to find out more, just Google Woodford Maintenance Compliance Program. It'll come up. And Daniel's going to co-host. Sorry, he's helping me out with the questions today. If you want to know more, you can talk directly to Daniel today. But he's doing a webinar on the topic anyway in a few weeks or so. So key considerations, and look, I've charged through these. For me, again, just to recap, these are the key considerations to in terms of the development assessment process. And whilst I know they can be considered challenges and problems, for me, it's a real opportunity to actually make significant improvement to help better protect our waterways. I know it's not easy doing the development assessment, and I know a lot of things can go wrong, but it's actually, if we can do it right, and there's a few things, as I've touched on today, that we can look to sort of particularly focus on, I think that's actually can turn basically a problem into a significant opportunity to help better protect our waterways. Cool. So thanks, guys. That's all I'm going to talk about today. These are my contact details if you want to talk to me later. But just remind folks, if you've got any questions, please put them in the Q&A panel. I'm going to put on my headphones because I know Daniel's going to be joining me to help me with the questions. But I know there's a few things come through in the chat, and I haven't looked at them yet. But if you do have a specific question, please put them in the Q&A panel. And it's generally a case of first served, first. Oh, sorry, I should stop sharing my screen because I see there's about 6 questions already in the Q&A. So thanks for that, Daniel. Do
Yep,
you want to
I'll
help me
take.
with that?
Yeah, no worries. So Michelle Gilson from Central Coast Council in New South Wales has said that most of those poor bioretention systems shown would need full pool fencing around them in New South Wales. Also, more than 0.3 meters storage depth equals pool fencing required. Also, not great for maintenance access. Not really a question, but more of a comment around, yeah,
No,
different
no
councils
disagreement.
require different things, but
Yeah. Yeah.
yeah. Going to the next question from Amelia Tatham from Northrop. So, do councils publish approved treatment rates, parameters for each product? Is this included in council's planning scheme?
Yeah, it varies. Thanks for the question, Amelia. So there's about 527 councils across Australia last time I counted, and they often have their own process. So, give you an example, Brisbane City Council do have a document that can be attained that outlines the product approvals and their performance values. Blacktown City Council obviously have the music nodes you can actually download from music. But yeah, if I'm honest, that's absolutely the exception to the rule. Most councils don't publish anything, which obviously makes it very difficult for consultants like you. Obviously, Ocean Protect, if you ever wanted to know what our approved values are for individual councils, you can just email us. But it does vary from council to council quite substantially.
Thanks for that. So Sean Quilty has asked, how many people rerun the music model in detailed design as opposed to just accepting the council-approved SBSMP and not checking detailed design complies with the concept?
Well, great question, Sean. Greetings. Sean's one of our presenters from the start of the year with the fundamental series, and he's lined up for 3 more next year. From Quality Engineering Group. Look, it's a great question. I remember back in the day when I was a consultant, one of the things I actually have to do every so often not always, was had to provide a verification letter. And I'm sure you did, Sean, or have, or still do, that you've actually done this very thing that you've talked about. So it goes from conceptual design, where you might have done a music model, it goes to a detailed design. There's probably some changes, catchment, sizes, et cetera, whatever changes. And then someone has to provide a verification, say, yeah, it's still hunky dory. So I used to do that for some projects. I'd say probably less than 20% of the projects I was involved with would actually ask for that. So I'd suggest if I'm honest, I'd probably say it's less than 10% of projects. Does anyone do anything like that sort of check? And as we know, there's a big difference between construction and conceptual design.
Thanks for that. So the next question comes from Ajaya Basnet. So they've asked, could the Ocean Guard basket installation in inlet pits achieve the 75% TSS treatment target?
Yeah, great question. No. And full disclosure, I've got a massive conflict of interest here. I work for a company that wants to sell you ocean guards. Uh, so an ocean guard, if I just describe very quickly, it's obviously a basket that sits within a pit and has a very fine, it's a 200 micron filter bag. Okay. And even with that, as per SQUIDEP, the verification, I think we achieve roughly about 51.7% off the top of my head. It's weird I remember these numbers. I think it's about 51% of TSS removal for the flows that actually go through the filter bag. Um, and now, even with a basket with a very fine filter bag, we don't achieve anything like the 80% removal target that was claimed and approved previously. So that gives you an idea of how some claims are certainly exaggerated for different devices. This is a big question. I might
Yeah,
have to read that.
yeah,
Do you want to read it?
you can read it if you want.
Okay, it's a question from Dan Ego Dewati. Apologies if I
From
mispronounced that.
Glenorchy Council in
Oh,
Tasmania.
greetings. Oh, we'll probably see you at the Tasmanian Stormwater Symposium. So hopefully meet in person, Dan. Great surname. Dan says, I've been advised from a competitor that SQUIDEP certification is limited to verification of claim pollution reduction rates. It does not take into account effectiveness as a functional asset, such as confined space entry, sustainable materials, proprietary servicing, consumables, servicing intervals, or the device's ability to capture the pollutant load without remobilization back into the stormwater outlet. Do you know whether this will be taken into account in future for SQUIDEP, or will that be done to the assessors to review and perhaps seek advice from industry experts to assist with that? So, first part of your question, Dan. Yeah, look, SQUIDEP verification is about the performance of the asset in terms of its ability to remove the determined or nominated pollutants, and it's generally suspended solids, total nitrogen, total phosphorus, gross pollutants. It doesn't in any way provide any assessment of the sustainability of the materials used or the entry requirements or anything like that. The verification is literally it achieves this up to whatever flow rate. Now, in terms of the second part of your question, the device's ability to capture the pollutant load without remobilization back into the stormwater outlet, that is absolute BS. Okay, so to give an example, so the Ocean Guard, off the top of my head, was monitored in the field for I think a year. A lot of our devices that have got SQUIDEP approval have been somewhere between a year or two. For Filterra, we've been monitoring that for over 6 years now, I think. The maintenance that's done, the maintenance on each of the assets is just consistent with just our guidelines around maintenance. So for Ocean Guard, I think off the top of my head, we recommend cleaning them out roughly every 4 months or so. So when you do this real world testing, it's assessing under real world conditions. So every event is a real world with typical maintenance requirements, and that includes the fact that every so often you might get some sort of weird thing happening. There might be a bit of a flow coming in that might remobilize whatever, or you might have a little bit of, I don't know, some sort of leaching or something like that between events. These things happen in the real world. And that is actually taken in consideration when it comes to our performance testing in the real world. So I think, if I'm honest, Dan, I think you're being led astray, at least in relation to that second part of that question. Is SQUIDEP, like I said at the start, is SQUIDEP perfect? No. But it certainly takes into consideration a bunch of factors, such as maintenance requirements. Hope that answers your question.
Thanks for that. The next question is for me about the
Yes,
Wizard
thanks, Ian.
Maintenance Compliance Framework. And so Job and Paul from Murray River Council in New South Wales asked whether the guideline for the Wizard Maintenance Compliance Framework is available, as it does say consultation draft on the images that Brad showed. And so there was a consultation period between April and August this year, so that was the consultation version of the document. It is publicly available, and I'm getting a lot of emails right now, people accessing it. So it is publicly available as a consultation draft version. I'm in the process of reviewing all the feedback and all the consultation to look to release a new version probably next year. But yeah, you're able to access that right now via wizardcompliance.com.au/resources.
Cool.
On to the next question. So Erhan from Tech Civil. During construction, we have come across contractors requesting we use alternative manufacturers as they claim they are cheaper for them. I note the manufacturers in question claim higher treatment rates and hence less filters, etc. How do you suggest we tackle this problem?
Yeah, it's probably our number one barrier as a business is that other suppliers of treatment technologies will claim um, exorbitantly high performances for their devices, but also they're cheaper. So yeah, we at Ocean Protect we've got obviously a range of technologies, and they're yeah, I'm biased. They're very effective at removing pollution. Now, anyone can throw a sock into a pit and say it does a better job for a much lower price. But my point remains that there's very little evidence to actually show that these devices actually work as intended. Now they will say, "Oh, the council might approve it," or just yeah, we've done some testing of the device and it works fine. Okay, show me that proof. Again, if you've got a manufacturer making such claims, just ask for the proof to be provided to you without any distribution restrictions, i.e., you could give it to someone like me to review and give you a second opinion. I just wouldn't blindly follow the advice of someone selling you a product. Hopefully that answers your question. And happy to have a conversation offline if you want to talk specific projects, etc.
Uh, so next question from Ina from Morgan Consulting Engineers. Can you go into flood immunity requirements for underground tanks containing filter cartridges or any other water quality treatment devices? I haven't been able to find much information about it.
Yeah, it's a great question. I used to come across this more for bioretention systems back in the day because there was a perception that, and it's reasonable that you don't want bioretention systems in particular being flooded from creeks and rivers, or whatever. But the problem is that those requirements do vary from council to council. So I think back in the day, I remember Ipswich Council at one stage required bioretention to have 1 in 100 year immunity. I don't think that's the case anymore, but it does change from council to council. So it's probably best, if you want to email me specifically about your project in question, I might be able to provide some specific guidance. Hopefully that answers your question a little bit. Because yes, there's nothing's clear. There's no definitive advice from Water by Design or anyone that I've seen. Hopefully, it might be wrong, but yeah,
Thanks for that. So Matthew Hafey from
yeah.
Toowoomba Council, can you tell us where the Toowoomba example in the integration section was located? And he would be happy for you to tell him directly. Maybe that's an offline
Yeah,
thing that you'd
I
be able.
meant to actually, yeah, Matthew, I meant to actually, because I know you emailed me this after I did the previous webinar. I actually didn't get around to actually finding where it is. I actually went to that site. I think it has to be at least 10 years ago. But I'll try and do a near map search and jog my memory to work out what it was. But I remember it was in a shopping centre car park. So there couldn't be too many shopping centres around Toowoomba. Famous last words. I don't know, but I'll try and find out.
Uh, so then from Edmund, is SquidUp a government body or a private organization?
Yeah, yeah. Edmund, SquidApp is actually a process. It's a protocol, and it's managed by Stormwater Australia. So Stormwater Australia is a not-for-profit organisation, basically an industry association for Australia, a Stormwater Industry Association for Australia. And their members are Stormwater Queensland, Stormwater New South Wales, and the other state associations. So it's a not-for-profit volunteer organisation.
The next question comes from Rob Booker. So music can indicate significant pollution removal in detention tanks, but no ability to store the pollution. What is recommended in relation to modelling these with and without cartridges?
Great question. So Rob's from Sunshine Coast Council. Greetings, Rob. Yeah, look, I didn't touch on this because it's not something we see too often nowadays. But and I'm going to talk techo for 2 secs, so apologies. But in music for detention node, you can actually change the K and C star values in the detention node. um, but and I see some manufacturers historically in some councils when they know they can get away with it, they'll leave the default values for K and C star, and that'll actually overestimate the performance of the combined asset. So when we model at Ocean Protect, when we're modeling, say, storm filters, for example, the cartridges or jellyfish, we make the K and C star value in the detention nodes basically, I think K is equal to 1 or K is equal to 0. And what that does, it basically negates any pollution removal associated with the detention node itself. Okay, so that means all the pollution removal provided by the storm filter cartridge setup happens in the generic node, which represents the storm filter, and zero pollution removal is associated with the detention node. So, and if you don't do that, you're double dipping where you really shouldn't be. So all the SQDAP approval rates, all the previously approved council approval rates, that's for the generic node, and that the performance of a cartridge system should only be in terms of pollution removal should be focused on the generic node, not the detention node. But again, to turn that off, K value should be 1 or 0. I hope that helps, Robert. I know it's hard to describe without a model in front of me. So if you want to talk further, just give me a shout.
Next question from Rajiv. What is your opinion about reactive filter media pillows, RFM pillows installed in the stormwater pits as a treatment measure?
Um, Again, I wouldn't want to comment too specifically about a particular product. My point remains, anything that is claiming some sort of pollution removal, the proof should be provided, and that proof should be provided without any distribution restrictions. So it can be appropriately reviewed by suitably qualified people. So in the absence of that proof, and I'm yet to see any proof for that device or devices, I'm going to say my opinion is skeptical.
For the next question from Mitchell Leeds, who is from, I think, from a Victorian council, has said,
Hmm.
being a rural council, we have limited resources for maintenance and none for ensuring private developments follow maintenance plans. Any advice on ways to deal with this or suggestions for less maintenance intensive WSID options? So I might
So I'd say talk to Daniel Ryder from Ocean Protect.
Um, Mitchell, I'll reach out to you after today's webinar and maybe we can have a meeting to discuss this. But I think what I'd recommend for people is to really look at the WSID Maintenance Compliance Framework. It is a very flexible framework that can be used to improve maintenance of private assets. Councils can use it in a way that works for them. There is a lot of flexibility and options with that, and I'm happy to help kind of figure out what that can do for your council. In terms of, yeah, limited resources, councils across the country have limited resources for maintenance and a whole bunch of other things. And I think, yeah, it can be hard to do. And I think if there's more strategic planning around public assets, where they go in terms of what types of assets are put in place and where private assets are and making sure private assets are getting maintained, there's a lot of things that can be done to help kind of with those limited resources. And so that's something, yeah, I'll follow up with you about after today and we can have a chat.
Cool. And there was a comment about, is there a less intensive WSID option? Yeah, look, I think the focus for me should be on resilience. Like all assets need maintenance. Some probably do need a little bit more than others, but I think the focus should be on maximizing the resilience of assets. Cool. And I think that's the end of the questions.
Um,
Then, Daniel, is there one more in the
so
chat I
in
haven't
in
seen?
the chat, there's from Christopher Scholes. Do you think as an industry we have become too reliant on music modeling as our almost singular and only tool to model and assess water quality controls? How can we change this where other tools are available to both consultants and councils?
Great question. Yeah, look, in short, yeah, I do think we've become way too reliant on a software package to determine whether a solution is appropriate or not. I always think of we should be looking at first principles as well, not just picking up a model, but talking about first up appropriate urban design and planning. Also, source reduction. I know that might be counterintuitive to come from a company that's trying to sell devices to, stop pollution in a pipe or going into the stormwater system. But yeah, if we can focus on mitigating pollution at the source, and there's a bunch of things you can do to do that. But certainly, just there's a whole bunch of checklists and design calculation summaries and sort of, I guess, procedures and guidance around just trying to achieve better water sensitive urban design outcomes. So I think there's a lot of tools that can assist. And certainly, I'd be picking up all of those before I picked up a software package, whatever that might be. How can we change this? That's another great question. Maybe we should hit pause on using models for 6 months and see what happens. No, just as a social experiment. I think we could go a long way to mitigating any need for water quality modeling if we sort of just accepted, okay, there's a certain amount of hydrologic effectiveness we want for devices, and there's certainly a standard device that we want or devices that we want to achieve. Now, back in the day, I think they still actually do water by design, and others had a deemed to comply solution. So if you just did a stock standard bioretention system at a size at a 1.5% of the upstream development, that would be enough to tick the box for small scale sites. Maybe that could be appropriate, and if it's not bioretention, it could be like a treatment train approach of some sort of pre-treatment like a gully pit basket plus cartridge and or bioretention system suitably sized to achieve a certain hydrologic effectiveness. These are all things that we could do without picking up a music model. So there's a couple of little things we could look to do. Certainly, I think the first step we need to consider is just challenging the status quo. Like, are we doing is what we're doing appropriate? And if it's not, let's have a think about as an industry or a group of stakeholders come together and talk about what we could do better. So that's what I'd suggest before I start talking about solutions. Cool.
That's it.
We've just gone over time. Look, there's one final question. Job, and Paul's come through. Is there options where if it goes unmaintained for a few years, there's no increased flood risk and can be brought back to like once council's budget? Yeah, look, there's obviously like the one that comes to mind is we've got a storm filter system we put in Menai in New South Wales 20 years ago, and it hadn't been maintained. Literally just get in there with a sucker truck, remove the sediment, and replace the cartridges, and it was good as new. So there's certainly scope to do that, not just for proprietary assets, but also vegetated systems as well. Look, we're flush out of time, guys. Everyone's been super generous. We might have to call it quits there. If you've got any further questions for myself, please email me there. And if you want to talk to Daniel, it's danielr@oceanprotect.com.au about the WSID compliance stuff, or just Google WSID compliance framework, and I'm sure you'll get in touch with Daniel. But again, thanks so much for everyone's time today. Much appreciated. We'll see you at the next webinar, and hopefully we'll catch up together in person soon. And thank you for Daniel Ryder for facilitating the Q&A. Much appreciated.
That's okay. See you, everyone.
Have a good day.